Hello students, today we're going to look at section 9.1, which is graphing quadratic functions. Now this is going to put to use all of the things that we've been doing with trinomials and binomials and factoring them, and we're going to use all of that information to lead into quadratic functions and graphing them and solving them and such. So today we're first going to learn about what quadratic functions are, and we'll go from there. So first of all, a quadratic function is a function described by an equation in the form of f of x equals ax squared plus bx plus c. Now remember that f of x can also be identified as y, so y is also ax squared plus bx plus c. And it's important to know that a cannot equal 0, and it never will this year. Okay, so an example is y equals 2x squared plus 3x plus 8. Now that looks familiar, it looks like a trinomial, and it is. And we're just going to do some stuff with that. Okay, so the parent graph of the family of quadratic functions is y equals x squared. And we're going to deal with parent functions later on, but you just need to know that the basic parent function is y equals x squared for quadratics. Graphs of quadratic functions have a general shape called a parabola. P-A-R-A-B-O-L-A. Some people call it parabola, but it really is a parabola. A parabola opens upward and has a minimum point when the value of a is positive. That value right there. If it's positive, that means it opens upward, and that is the minimum point. And a parabola opens downward and has a maximum point when the value of a is negative. If that a is negative, the parabola opens downward, and so that is the maximum point. So let's look at some examples that we have down here. We have use a table of values to graph y equals x squared minus 4x plus 1. So we chose some random numbers from -1 all the way to 4. Plugged them in to this equation for x, and we got the y's here. And then we graphed those. The first one is -1, 6, -1, 6, 1, 2, 3, 4, 5, 6. So it would be right there. 0, 1, right there. 1, -2, 2, -3, 3, -2, 4, 1, and we could go on and on and on, but we just stopped at those values. And you see when you draw it, you draw this kind of smooth curve, and we have, because a in this case is +1, that means it opens upward. So this point down here at the very bottom is the minimum point. And if we look over here, first of all, and it says, what are the domain and the range of this function? Well, this year the domain is always going to be all real numbers. So the way we write that is the negative of infinity is less than x, which is less than positive infinity. And so that's the domain. Again, this year, that's the domain, always. And you probably need help seeing that. The range, on the other hand, is going to look at the y values. And the y values, if you'll notice from the graph, start at -3 and go up. So the range would be y is greater than or equal to -3. Because every y value, you can look on the y values here, every y value is above the -3, and -3 is the lowest point. It's the minimum. So all of the y values are going to be above it. So let's look over here at example number 2. Example number 2 has the equation y equals -x squared minus 6x minus 7. Again, we picked some different points. You're probably wondering, well, why did we pick -6 to 0 instead of -1 and all that? Well, we're going to show you in the calculator how you can figure out which points are best to use, because we needed to find our values that are easy to graph. So we plugged in all those numbers, we got our values, and the first one is -6, -7, -5, -2, -4, 1, -3, 2, -2, 1, -1, -2, and 0, -7. There's our points. We graphed them. We created a smooth curve. And you'll notice that those lines with the arrow, well, they're actually not lines, the curves are going to go on forever. Okay? So what are the domain and range of this function? Again, the domain is always the same. The domain is the negative infinity, which is the, ooh, that's bad, which is less than x, which is less than the positive infinity. All real numbers. The range, again, we have to look at our range of y's. It looks like the top number is 2 for the y values, and they're all less than that. So y is less than or equal to 2 because we have a maximum point. That y value is 2. All the other y values are below it. That is the range for that function. Something I want you to notice is the y-intercept. If you go over here to this function and you see the y-intercept, which is where the parabola crosses the y-axis, notice it's 0, 1. And if you look over here at the y-intercept where it crosses the y-axis is 0, -7. It appears to me that the y-intercept is given to us in the equation. That's another way to help you graph, and we'll talk about more of that later. So now let's look at a couple of examples down here. I'm going to do one of them together with you, and then I'm going to let you do one on your own. So y equals x squared plus 2. Use a table of values to graph each function, determine the domain and range. So I'm going to create my table of values with x and y. And typically we would start with -2, -1, 0, 1, and 2. And let's see what happens. So -2 squared would be 4. 4 plus 2 is 6. -1 squared would be 1, and 1 plus 2 is 3. 0 squared is 0 plus 2 is 2. 1 squared is 1 plus 2 is 3. And 2 squared is 4 plus 2 is 6. Okay, so we'll graph these points. -2, 6, 1, 2, 3, 4, 5, 6. -1, 3. 0, 2. 1, 3. And 2, 6. And so I would draw my smooth curve, making sure to get all the points, and we put arrows because it goes on forever. Okay. Now, the domain, you guessed it, -infinity is less than x is less than infinity. And the range, look at our y values. The lowest point is a 2. Everything's above that. So y is greater than or equal to 2. I want you to notice the y-intercept. The y-intercept is 0, 2, which still is c. And you'll notice on this one, there's no bx in there. It's just ax squared plus c. That's important to know as well. So what I want you to do for part of your practice problems is to graph numbers 2 and 3. And then you're going to take a picture of this page, but we're not finished. There's more.